Okay, so the final example to do with friction is going to be on an inclined plane. So we've got a particle of mass 2 kilograms sliding down a rough slope that is inclined at 30 degrees to the horizontal. Given the acceleration is 1 meters per second squared, find the coefficient of friction mu between the particle and the slope. So start by drawing a nice clear diagram. So we've got horizontal ground there, we've got the slope which is at 30 degrees, we've got the particle here which has got a mass of 2 kilograms, and we want to label on all the forces. So we've got the weight of the particle, which is 2g. The friction force is going to oppose the motion. So the particle is sliding down the slope. Friction is going to be going the opposite direction. And we also have a normal reaction force. So the acceleration of the particle is 1 meter per second squared. So we'll label that as well here. The question is going to be to do with resolving parallel slope and perpendicular slope, as we've done with other inclined planes questions. So if I draw on this triangle, so those of you who looked at inclined planes, this should be familiar. The idea is that this part of the weight is perpendicular to the plane. This bit is parallel to the plane. The angle here is the same as the angle of the slope, which is 30 degrees. So this component is 2g cos 30 because it's adjacent to the 30. Cos 30 is root 3 over 2. So this is going to simplify to being g root 3. This bit is going to be 2g sine 30 because it's opposite the 30 degrees. Sine 30 is a half, so this is just equal to g in fact. And then we want to resolve in two directions. So we're going to resolve parallel to the slope first to get one equation, and we get another equation going perpendicular. So resolving parallel to the slope, there's only two forces parallel to slope, which are G and F. So G take F is equal to the mass times the acceleration, so 2 times 1 is 2. So in other words, G is going to be equal to 2, so whatever the friction is, and we'll come back to that in a moment. If we resolve perpendicular to the slope, then we've got two forces again. We've got R and G root 3. So R take G root 3. This time it's equal to 0 because the block is sliding down the slope. It's not bouncing along or anything daft like that. So in other words, R is G root 3. And from there we're going to be able to work out what the friction force is. Because the particle is actually sliding down the slope, we've reached the point where we've gone beyond limiting equilibrium. So we've reached the maximum value of friction. So the friction is just equal to mu r, and that's because the block is moving, or the particle rather. If we were just told that it was resting there, then we wouldn't necessarily know that. Okay, so mu, we were told in the question, is just mu. That's what we're trying to find out, of course. So we've got mu times by r, which was g root 3. And then we can substitute that into the equation up here that we worked out before. So that's what F is going to go into that equation. So we've got G is 2 plus mu G root 3. So G take 2 is equal to mu G root 3. So we just need to divide by G root 3 to find what mu is. So that's written as an exact value, but I suppose we probably just want to get a decimal approximation to that. I get 0.460 to 3 significant figures. It's a pure number, so there's no units with it, so that is then the answer to the question.